Good afternoon, class. In this screencast, I'm going to talk about relational algebra's division operator, which is not discussed in the textbook. As you can see, I'm using materials from Lester McCann. So division is defined in terms of three operators, which you have read about: projection, subtraction, and cross product, and six total operations: three projections, two subtractions, and one cross product. And as noted on the slide, it's based on finding values that are not answers to the question that's asked. So division is useful for situations such as the following question: find those faculty who have taught all courses. Let's look at an example of that. That's the key. Finding the opposite of what you want, right, and then negating that to get your answer. So here's an example to show how in division we're looking at getting the negation of our final answer. So in this example, we're going to find those faculty who have taught all courses. We have a rather small universe here, just three courses: CS 119, CS 205, and CS 317, and three faculty: Jill, myself, and Justin. You can see the taught relation, and just through inspection, you can see that Jill's taught all courses. Now we're going to go on and get the insight into how we compute this sort of an operation in relational algebra. So you can see that taught is a subset of faculty crossed with courses. So if we go ahead and compute faculty cross courses, we get a relation with 9 tuples in it, which you can see there. Now, think about what happens if we take faculty cross courses and subtract the taught relation from it. Jill's taught all the courses, right? So when we perform that subtraction, any tuples with her name in them will be removed completely. So we've lost the answer, but continuing to think about that, the tuples that will remain, in this case tuples with my name and tuples with Justin's name, are the negation of the answer. You can see that there on the final bullet. Faculty cross courses minus taught gives us 1, 2, 3, 4 tuples, right? The one CS course that I haven't taught, and then the 3 CS courses that Justin hasn't taught. So the negation of the answer here is Tom and Justin, right? Negating that gives us Jill, which is the quotient of the division here. Okay, so here's a slide explaining what division is, right? This is another way of saying that we're looking for those elements of a relation that are related to all, those tuples of relation that are related to all tuples of some other relation. And again, it is just the inverse of the Cartesian product. So here's an example Cartesian product. So we have relations M and N, and their Cartesian product O. So O divided by N gives us M. Right here is N, and 4 from N is paired with all the tuples of N, and 8 from N is paired with all the tuples of N. Similarly, O divided by M gives us N. 3 is paired with 4 and 8. 1 is compared with 4 and 8. 7 is compared with 4 and 8. Now imagine for a second if this tuple were removed from O, then O divided by n would just be 8. And again, keeping in mind, we remove this tuple conceptually. O divided by m would just be 1 and 7. So here's a rather famous example involving a parts relation, a suppliers relation, and a jobs relation. We'll be working with a simplified version of this when we start working with SQL, using just parts and suppliers. So the parts relationship, we have a part number, part name, color, weight, and city. There are two other relations for supplier and jobs, and then the relation subject part job, which relates the parts, suppliers, and jobs relation. So in this example, we want to find the supplier numbers of those suppliers that supply all parts of weight equal to 17. Now to do that, we're going to create a relation alpha from the relation SPJ and a relation beta from the relation P. So here's how we construct alpha. It's just the projection on these two attributes of SPJ, and beta is the projection on the attribute part number where the part number weight, we're using selection here, is equal to 17. Okay, so again, the idea is to find the values that do not belong in the answer, and then we'll remove those from all of the values that could possibly be in the answer. So the list of possible answers is the projection on the serial number of the alpha relation. Now, you may want to go back and look at the alpha relation. Now here we construct gamma, which is the cross product of supplier numbers with those part numbers with a weight of 17. So remember, gamma is the superset of alpha, right? Because gamma is the cross product of supplier number and part number. So if we take gamma and subtract alpha from it, we'll have the same situation as we had with the course and faculty example, that gamma minus alpha gives us the supplier numbers that don't supply all those parts of weight 17. All right, so here's the subtraction. So delta here is those tuples in gamma that are not in alpha. Now, there's some noise here in alpha, so let me remind you what's what here. Gamma was the cross product we constructed from the supplier numbers crossed with the part numbers of those parts with a weight of 17. Right, so only part 2 and part 3 had a weight of 17. So the beta table just had the tuples for P2 and P3. Alpha was the supplier number and part number attributes from the SPJ table. So that contained some information that is extraneous. For example, the first tuple there, supplier 1, part 1. Part 1 didn't weigh 17, so it's not really something of interest. But in terms of the subtraction, it doesn't hurt anything, right? Because of the way subtraction is defined, right? Subtraction delta there is those tuples from gamma that are not in alpha. So you can see in gamma, the magenta tuples are those that are being removed. Delta, when you think about it, you can think about it as those parts of interest, i.e. weight of 17, that are not supplied by the supplier. Right, so you can see there, supplier 1 supplies neither of the two parts. Supplier 2 supplies part 3, but not part 2. So any supplier that is not in delta supplies all of the parts of weight 17, right? In this case, that's a supplier 5. Okay, then to finish the division, all we have to do is to take the projection on supplier number of alpha, giving us S1 through S5, subtracting from that the projection on supplier number of delta, which is S1 through S4, giving us S5, which is the quotient of the division. So here in a nutshell is the division. Alpha divided by beta. Let's start here. Right, so remove those attributes from A that are in B. Right, so the projection of those attributes in A that are not in B on alpha. Cross that with beta. Subtract alpha. Now, from that subtraction, project the attributes in A that are not in B. Subtract that from the projection of the attributes in A not in B from alpha. Put more simply, compute all possible pairings, subtract the existing pairings. That gives us the non-answers, so remove the non-answers from the possible answers, and that gives us our quotient.